Well, look who's come back for a bit of maths here at Nick Does Maths. I have an absolute doozy for you today. Absolute doozy. We've got this polynomial fraction, a quartic on top and a quadratic on the bottom, but we've got this unknown parameter a in there. What we do know is if I sum up f of r from r is 1 to n, I end up with this expression. What is a? Wowzer. Okay, we've got quite a few steps to go through here. So number one, probably, hopefully, one would hope, is that we can see that the first thing we want to do, I've got a quartic over a quadratic. What I want to do is I would quite like to get this as some partial fractions. Now, it really does depend on how you want to do this. Okay, you could try and make some thing of that one appear on top. You could try and do the long division. Personally, I know what I'm going to use, which is the fact I've got a quartic divided by a quadratic. So I should end up with a quadratic of some description. Now, they've already used an a, which is great fun. So br squared plus cr plus d, plus I'll get something over r plus something over r plus 1. And what we are going to do is we are going to try and find all the missing things. We're going to try and find all the missing things. Right, so where's the space for this going to be? Where's the space for this? Right. So I'm going to multiply it all up. So I end up with f of r times r plus 1. And you know what? That's just going to drive me nuts. It's just going to drive me nuts. I was trying to be concise, but 6r to the 4 plus 6r cubed minus ar squared minus ar plus 1 is equal to br squared plus cr plus d times r plus 1 plus e r plus 1 plus fr. Now, we can use a host of different techniques to do this. I am actually going to start by just comparing the coefficients, because some of these coefficients are very, very easy to pick out. So if we look at the coefficient of r to the 4, on the left-hand side is 6. And on the right-hand side, there's only one term that's going to give me an r to the 4. It's the br squared times r times r. So it's already telling me the b is 6. Good job, everybody. In the same way, actually, we can get r cubed quite easily. After this, I will stop with the coefficients. So 6r cubed. On this side here, how can I get an r cubed? Well, I could get a br squared times r times 1, so I could get b of them. And I could use cr times r, so I could get plus c. So that does tell me, in fact, that c is 0, so that's quite handy. It does already tell me that c is 0. And after this, we're just going to have to put some numbers in. Now, r is 0 seems like a good plan. We could keep doing this, in fact. We could look at the coefficient of r to the 0. That's probably quite a good one as well, because it's 1 on that side. That will give me no r to the 0. That's an r. So it'll just be e. So it tells me that e is 1. So we've really got e as 1. So this is going quite well. We got e as 1. We got c as nothing. And I've got b as 6. I mean, it's going pretty well. It's going pretty well. Let's try plugging in r is 0. Let's try plugging in r is 0. So on this side here, I get 1. That'll just give me e. That'll just give me e. So that's not as useful anymore. How about I plug in minus 1? 6 minus 6 disappears. Minus a plus a disappears. So I still get 1 on that side. That disappears, that disappears. Oh, that's minus f. So we get f is minus 1. Ooh, OK. All right, we need to figure this guy out. Well, I suppose let's just put a value of r in. Let's put r is 1. Let's put r as 1 in. So 6 plus 1 is 13. Minus 2a is equal to b, well, c is 0, b plus d, so 6 plus d, times 1 times 2 times 2, okay, that worked, plus 2e, which is plus 2, plus f, which is minus 1. That's 13 minus 2a is 12 plus 2 minus 1. Oh, 13, that's nice. Plus 2d. So that one, in fact, will tell me that d is minus a. Alrighty then. Let's go. Let's go. All right. So we got our partial fractions. Okay. I'm going to just put this down here because this is my target. N squared, n plus 2, 2n plus 1, n plus 1, because then I can use more space on the board. So the sum of all of this is going to be, and what's quite nice is I actually know some of this, right? That is the sum of r squared. Well, luckily for me, I have a result for that. Minus a, the sum of just 1. I have a result for that. Plus the sum of 1 over r minus 1 over r plus 1. And this we might be able to see coming a mile off. We know what this is because this is going to be method of differences. And as always, let's just start by putting a few terms in. So let's put in for 1, put in for 2, put in for 3, etc. But what we can see is everything is going to cancel out. Bosh, 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 bosh. And we'll be left with the first and the last term. So putting all of this together, I end up with 6 times the sum of r squared, which is 1/6 n, n plus 1, 2n plus 1. That is minus an. And then this has been a difficult one for the board, all right? I won't fib to you. Plus 1 minus 1 over n plus 1. Now, when you look at our target over here, that is actually quite reassuring because that's an n plus 1 down there. We've got an n plus 1. So let's see what else we can do. Also, the 6's going away is also quite a good one for me. I won't fib on that either. I need to put this somewhere so I can come back to it. It's just taking up precious board space, y'all. Okay. Well, I mean, I know what I need to do, but I really, 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 really don't want to. So if I don't want to, do you think I can not? Do you think that would be... Ugh, okay. All right, fine. Fine. What does this expand to? We will get 2n cubed. But do I want to do that? I'm not sure I have a choice. Do I have a choice? I'm not sure I have a choice. Okay, I'm not sure I have a choice. 2n cubed, 2n, 3n plus 3n squared plus n minus an plus 1 minus 1 over n plus 1. Okay. Now I'm going to multiply this out by n plus 1. So we are going to get 2n to the 4 plus 3n cubed plus n squared minus an squared plus n plus 2n cubed plus 3n squared plus n minus an plus 1 minus 1 over n plus 1. Please, please, all the lords of Valhalla, I hope this worked. Bosh, bosh. Now, fundamentally, what do we know needs to happen here? Those ones have cancelled out. I should, now looking at this, I should be able to take out an n squared. I should be able to factorize out an n squared, which means the n terms need to cancel out. So I need 2n minus an to be 0, so that should tell me that a equals 2. So this is my proposed answer, a equals 2. Now if I have a equals 2, what does this become? What do I end up with? Again, we're going to have to... If I take a is equal to 2, what do we end up with? We will end up with a, 2n to the 4. 3n cubed, 2n cubed, 5n cubed. Okay. Now n squared, 1n squared, 3n squared, 4n squared, minus 2n squared, plus 2n squared. That works for me, and then that's it. Over n plus 1. Take out the n squared to get 2n squared plus 5n plus 2. Does that do what I want? 2n, n, plus 2 plus 1. Yes! Awesome. So, a equals 2. Might want to take a few screenshots of that as you go through, as I cannibalize my board space as I go through that. But that was pretty satisfying. Terrifying at first, right? Trying to actually do partial fractions on something with an a in it, not fun at all. Did you try and do the long division? Did you try anything else to get those partial fractions out? Let me know. What's your preferred approach? How do you feel about my mixing of looking at coefficients and just plugging in values of r? How do we feel about that? Right, bringing all of these ideas together to try and get the bits that we can where we can. I quite like doing that. I quite like doing that. This was terrifying, however. But because we knew what we wanted to get to, right, because we knew what we wanted to get to, we knew the ones had cancelled out, we knew the ends had to cancel out, so we could make a couple of jumps there. But always worth checking at the end. All right, that was me, Nick, checking out for this video. Please don't forget to like, subscribe, leave a comment, all that good stuff, and hit the notification bell wherever it may be on the screen, down there, down there, down there, so that you know when the next one is coming out. And I will see you soon. Bye-bye.